Hello, algebra students. Mr. Lawrence here. Yeah, my car is still broken down. I'm riding on my horse. Anyway, that was a little joke. Bum. All right, let's see here. I'm going to do problem number 4 from your homework. Second period, this was your homework tonight. And 7th and 8th period, this is your homework from 2 days ago. I'm going to mention a few things that I want to reinforce. Okay, we talked about them in class today, but anyway. It says Derek tosses a softball directly upward with an initial velocity of 100 feet per second. And remember, I told you to say that the initial height, the starting height, was 5 feet. I accidentally left that out of the story, and you can't do it without it. Okay? Now, before I actually go and do these problems, I'm going to read A, B, and C, and then decide what type of problem it is. So it says, when will the ball hit the ground? When? That's a measure of time, isn't it? I need to know the time. If I'm looking for the time, this is a quadratic formula problem. Okay. So B, when will the ball hit the ground? Again, when? That's a measure of time. This one will be a quadratic formula problem. Okay. How high did the ball go? Height. How high is it going? That's a vertex question. Yeah. Vertex. All right, now you might say the second part, how long did it take to get there? You might go, oh, well, that's going to be quadratic formula. It could be, but I think you'll see in a minute why I wouldn't use the quadratic formula on that. All right, so now that we know this, let's write our first equation. So we're going to have h equals negative 16t squared plus 100t plus 5. Because remember I said the starting height was 5 feet right up there, right? Okay. When will the ball reach 84 feet? Well, what is this? This is a height. I look at this equation, there's only one h that's unknown. This 84 must go in for h. And so then I'm going to subtract 84 from both sides. And I'll get 0 equals negative 16t squared plus 100t minus 79. And now it's time for the quadratic formula. So I'll go A, B, C. Easy as negative 16, 100, negative 79. All right, if I want to find the discriminant, I can. You know, that might make my work a little bit easier. I'm going to have to find it at some point, b squared minus 4ac. So I'm going to take 100 squared minus 4 times negative 16 times negative 79. So 100 squared minus 4 times negative 16 times negative 79. And when I get that, it's going to be 4,944. All right, so t is going to be equal to negative 100, negative b, plus or minus the square root of the discriminant all over 2a. Okay, so t is going to equal negative 100 plus square root of 4,944, which I don't believe is a perfect square. I don't believe that is the case. Let me just double check that. No, definitely not. And that'll be over negative 32. And then we're also going to have that t is equal to negative 100 minus that same square root, the discriminant, and divide by negative 32. Okay, so at this point I can go to my calculator. Hold on a second here. All right, so in parentheses I'm putting negative 100 plus the square root of 4944. Close that quantity and divide by negative 32. I don't think it's going to like that. Nope, didn't like that. It doesn't like that minus sign I use. I bet I can fix it here. Yeah, the calculator doesn't know that a negative and a minus sign are the same thing. Let's see if it'll let me do this. No, it's not going to let me do that. Okay, so I'm going to change it this way. There we go. And so I get, go to, it's probably because I wasn't using the airliner. I should have been. Yep, there it is again. Didn't like that negative. Okay, now it should work. There we go. So it'll reach the height of 84 feet in about, what was it, 92 hundredths of a second? 93 hundredths if I round that. Okay, so t will be approximately equal to 93 hundredths seconds. So that'll be the first time, okay? And then the second time I'll get by doing second enter and just changing that plus to a minus. All right, there we go. And so I'll get 5 and 32 hundredths seconds. So then t will be approximately equal to 5 and 32 hundredths seconds. Now, does this make sense? It should, because had I drawn a picture, which I really like to do, okay. Now this ball I think is going straight up and down. So it's going to kind of do that, right? So it's going to hit that height here on the way up, and then it's also going to hit it here back on the way down, and time is going to transpire. It looks better with, you know, the more blown out parabola like that. But in reality, that's what's happening. So it's going to hit here, and then again over here. All right, so I'm convinced that it makes sense. So let's go on to part B. Part B says, when will the ball hit the ground? Well, that's a quadratic formula again. Only this time, capital H, or I'm sorry, the ending height is not going to be 84. The ending height is going to be 100. No, Mr. Lawrence, it's going to be 0. Yeah, it's going to be 0. Just trying to give myself some work here. Give myself room to work. Sorry about that. So I can go right to 0 here. And that makes A, B, and C negative 16, 105. Now to find the discriminant, I'll do 100 squared minus 4 times negative 16 times 5. And so when I do that, I get 10,032, 320, excuse me. That's my discriminant. So now I go t equals negative 100 plus or minus the square root 10,320 divided by negative 32. There's two answers here. Whoa, what just happened there? That was crazy. Oh, all right. The gremlins must have gotten into my airliner again. Okay, so let me write that discriminant under that. 10,320, and that'll be over negative 32. All right. I know this one's going to yield a negative time, so I'm not even going to worry about it. If you don't know that, go ahead and do the calculations. All right, so here we go. I'm going to go negative 100 minus the square root of 10,320. Close that quantity, divide by negative 32. And there I go. I get about 6.30 seconds, so 6 3/10 seconds. So it'll hit the ground in approximately 6 3/10 seconds. All right, last part of the question. How high did the ball go? It's a vertex. So I'm just going to find the vertex. Sorry about that. All right, give myself some work here. All right, so some of you just do negative b over 2a. I'd really like you to leave the t in, because hopefully it'll remind you that you're finding a time, not a height. So I'm going to do negative 100 over negative 32, and that's going to be 3 and 125 1,000ths. All right, so I take that and I plug it in to figure out h. All right, so negative 16 times 125 squared plus 100 times 3.125 plus 5. And I end up with a height of 100. Height is going to equal 161 and a quarter feet. And so that's how high the ball will go. Okay, so it'll go that way. Now, how long did it take to get there? You don't need to go back and use the quadratic formula because you already know right there. So it'll take 3 and 125,000 seconds. Or if you convert that to a fraction, it's going to be 3 and 1/8 seconds. All right, there you go. That's some help with your homework. Mr. Laurence signing off. Have a good night, everybody.